What would you say if I told you that there is a frozen galaxy wandering through the universe for billions of years like a living fossil? This fascinating discovery was recently made by the James Webb Space Telescope, which identified a galaxy so ancient and inactive that it resembles a true relic of the cosmic past. This galaxy, which hasn't formed new stars for billions of years, continues to exist but has remained practically unchanged. How is this possible? What does this fossil galaxy reveal about the history of the universe? A fossil galaxy is a galaxy that stopped forming new stars long ago and is composed primarily of very old stars. It has undergone no significant changes for an extended period, sometimes billions of years. These galaxies are considered remnants of ancient epochs, often dating back to the early stages of the universe, and they provide an essential window into its evolution. Fossil galaxies are one of the most intriguing discoveries in modern astronomy because they allow us to explore the primordial universe, an era about which we still know very little. Throughout cosmic history, galaxies have evolved in very different ways. Some have continued to form stars and grow, while others stopped doing so after a relatively short period. Why did some galaxies freeze so early while others kept evolving? And what enables these galaxies to survive without forming new stars for such a long time? These are the questions astronomers are asking, and the James Webb Telescope might finally provide some answers. The galaxy recently identified by James Webb is an extraordinary example of this kind of living fossil. It is a galaxy that went through an extremely rapid star formation phase, producing billions of stars in a short amount of time. This phenomenon is known as a starburst, which occurs when a galaxy experiences rapid and intense star production, often due to a galactic merger or other cataclysmic events. During this phase, the galaxy takes on a perfectly elliptical spiral shape with a very high stellar density. However, after this explosion of star formation, the galaxy ceased to produce new stars, as if a switch had been flipped. Since then, the galaxy has remained practically frozen, with the already formed stars slowly evolving over billions of years. This freezing of star formation is one of the most fascinating mysteries of these fossil galaxies. Why does a galaxy like this stop forming new stars while others continue to do so? One reason could be the distribution of gas within the galaxy. When a galaxy has exhausted much of the gas needed to form new stars, it may enter a state of stasis, as seen in fossil galaxies. Additionally, the influence of dark matter and dark energy could play a significant role in this process, limiting the availability of material for star formation. Although scientists have identified these phenomena, their understanding remains incomplete. One of the most surprising features of these fossil galaxies is their ability to exist for billions of years without undergoing significant changes. Their long-term preservation is almost a scientific miracle, possibly due to a delicate balance of various factors, including the stability of dark matter, the distribution of gas, and gravitational effects within the galaxy. A famous example of a fossil galaxy is NGC 1277, located in the Perseus galaxy cluster, about 220 million light-years from Earth. This galaxy is one of the most striking examples of a fossil galaxy. Its stars are all very old, with ages ranging from 10 to 12 billion years. This means that most of these stars formed very early in the universe's evolution when the universe itself was only a few billion years old. What makes NGC 1277 even more interesting is the fact that, unlike other galaxies, it hasn't formed new stars for billions of years. Essentially, it has remained frozen in its original state. This behavior raises questions about why some galaxies, like NGC 1277, have managed to maintain such enduring stability while others continue to evolve through the birth and death of stars. One of the most remarkable features of NGC 1277 is that, despite its advanced age, its stars are particularly long-lived and stable. The stars in NGC 1277 are metal-poor, resembling those formed in the primordial universe. This is a peculiar aspect because it was generally thought that metal-poor stars could not survive for long. However, the stars in NGC 1277 seem to defy this theory, reaching very advanced ages without burning out quickly. Astronomers are still investigating why these stars have evolved so stably. It is possible that an unknown mechanism, perhaps related to the presence of a supermassive black hole at the center of the galaxy, has contributed to slowing evolutionary processes within NGC 1277, allowing its stars to maintain exceptional stability for such a long period. Another fascinating aspect of NGC 1277 is its supermassive black hole, which accounts for about 14% of the galaxy's total mass. This is an exceptionally high value, as in most galaxies, supermassive black holes make up only a small fraction of the total mass. The black hole in NGC 1277 could have a significant impact on the galaxy's behavior, such as preventing continuous star formation or influencing the distribution of gas. In many galaxies, supermassive black holes constantly consume surrounding matter, leading to the death of stars and the dispersion of gas. However, in NGC 1277, this process seems to be somehow frozen, leading the galaxy into a prolonged phase of stasis. Astronomers are working to understand whether the mechanisms associated with this black hole have stalled and how this may have contributed to maintaining the galaxy in an evolutionary freeze. Another incredible cosmic phenomenon recently discovered by James Webb is the phenomenon of Einstein rings, a theoretical prediction made by Albert Einstein over a century ago. These perfect rings are the result of a phenomenon known as gravitational lensing, which occurs when light from a distant object is distorted by the gravity of a massive object, such as a galaxy cluster. In some cases, this distortion produces a perfect ring of light. The James Webb Telescope recently captured the image of one of these rings around the galaxy SDSS J1226 plus 2149. Thanks to its extraordinary ability to detect infrared light, Webb was able to observe this effect with unprecedented precision. Einstein rings are not only fascinating from a theoretical perspective but also highly useful for astronomers. The gravitational lensing effect acts as a natural lens, magnifying objects behind it and allowing astronomers to observe extremely distant galaxies and stars that would otherwise be invisible. The discoveries made by the James Webb Telescope are opening up new horizons in our exploration of the universe. Thanks to its extraordinary ability to peer through cosmic dust clouds and capture infrared light, Webb is helping us better understand the evolution of galaxies, the dynamics of supermassive black holes, and the mysteries of dark matter and dark energy. The future of astronomy is incredibly promising, and each new discovery brings us closer to understanding the history of the universe and our place within it. Fossil galaxies, with their ancient and mysterious stories, represent a fascinating chapter in this narrative. A narrative that James Webb is unveiling, step by step. Thank you for watching. Don't forget to like, subscribe, and activate the notification bell to stay updated on future videos.